Hi friends, welcome to another math video with Ms. Deering. If you have this math book, the things we're talking about are on page 187. It's chapter 14, and it's all about geometric solids and volume. A 2D shape is something that's flat. You know a lot about 2D shapes. They're the shapes that you learn when you're little. They're circles and squares and triangles. 3D shapes have volume. They take up space. They are as if you took a 2D shape like a circle and you were able to stretch it out like a slinky till it had space. This is called a cylinder. It has two ends that are circles, but it's stretched out and takes up space. Another geometric solid that's probably really familiar is a cube. It has a square on one end and a square on the other end, and it's stretched out until you can see that all of the faces are square. If we stretched it out even further, we'd end up with what's called a rectangular prism. Even though one end is a square and the other end is a square, and they're stretched apart from each other, they're stretched farther apart, and so the sides are not squares, they're rectangles. So we call this kind of geometric solid a rectangular prism. Volume is the way we measure how much space is taken up in an object. This little rectangular prism is made of unit cubes, and we can count up how many unit cubes it takes to make this little rectangular prism. So what do we mean when we say that something is three-dimensional? We're used to measuring things like squares, and they have width and they have height, and now we're adding on a third dimension, and it's the length. And we can multiply all of those measurements together to find out how much space something takes up. Let's use this rectangular prism to show how that works. If we look from one end, we'll see a square, and we'll see that the width of this square is 3 units, and the height of the square is 3 units. And if we turn it, we can see that the length is 10 units. Let's see how that works. The length was 10. The width of the square that we first looked at was 3, and the height was 3. We can multiply all of those together to make 90. 3 times 3 times 10 is 90. Let's check. 10, 20, 30, 40, 50, 60, 70, 80, 90. So by multiplying width times height times length, we found out how many cubic units were in this rectangular prism. 90 cubic units. Area is two-dimensional. We measure it in square units. So here's a square. It's flat, it's two-dimensional, and we measure just the width and the length and multiply them together to get square centimeters. This one is 10 centimeters by 10 centimeters, so that's 100 square centimeters. And the way we write that is with a superscript 2. And here's a trick. Centimeters squared is what we use for a two-dimensional object. Volume is three-dimensional. We measure it in cubic units rather than square units because each unit is a cube shape. So let's test it out with this geometric solid. We can remember our formula of length times width times height and multiply those all together and find out how many little yellow cubes are in this geometric solid. So we can see that it's 5 times 10 times 10. So that equals 500 centimeters cubed. And here's the trick again. The 3 on the centimeters cubed matches the 3 in the three-dimensional shape. And remember, even though you can't see every single little yellow cube in this geometric shape, you know that they're all inside there, and that if we were able to break these all apart, there would be 500 little yellow cubes. Sometimes we want to find out the volume of shapes that are not rectangular prisms, but sometimes they're composites of familiar shapes. For example, this one has a rectangular prism that is 2 by 3, and this little rectangular prism sitting on top, which is 1 by 2. And we can add up these 6 unit cubes with these 2 unit cubes for a total of 8 unit cubes. And even though you can't see the 2 unit cubes that these are sitting on top of, you know they're there when you're counting up unit cubes to find the volume. When we talk about geometric solids, we have some special vocabulary that we use. Geometric solids have faces and edges and vertices. Faces are two-dimensional and flat, so with a cube, all of the faces are square. And edges are where 2 faces meet, and vertices, that's a fancy word for corners. Vertices are where edges meet. So a cube has 6 faces and 12 edges and 8 vertices or corners. So this is a triangular prism. We talked about that as being a triangle that you stretched out. And so it has 2 faces that are triangular shaped, but it's got 3 faces that are rectangle shaped. So it has 5 faces, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And let's count the corners. 1, 2, 3, 4, 5, 6 vertices. This geometric solid is not a triangular prism. It's a special shape called a pyramid. It has a fancy name called tetrahedron. All 4 of its faces are triangles. There are different kinds of pyramids, and they're all classified by what shape is on the base. This one has a triangle on its base. It has 4 faces that are all triangles. It has 6 edges, and it has 4 vertices. Let's compare a triangular pyramid, which has a triangle as its base and those 4 triangular faces, to a square pyramid, which has a square as its base and 4 triangular faces. This is the kind of pyramid, when you think about a pyramid in Egypt or Ethiopia or Mexico, those fancy pyramids are all square pyramids because they're built on a square base. Thanks for watching. I think I'm going to go reduce the volume of these geometric solids.